I'm glad to introduce our first keynote speaker, Mr. Michel Charron. Mr. Charron was appointed as Hydro-Québec Vice President of Construction Projects in 2024. As such, he is responsible for all construction projects that Hydro-Québec must carry out to achieve the objectives set out in its Action Plan 2035. He also oversees activities related to the environment and real estate at Hydro-Québec. Before joining Hydro-Québec, Mr. Charron worked at Rio Tinto Alcan and subsequently at Rio Tinto for 17 years. At Rio Tinto, he held executive positions with a focus on developing large-scale projects and operating major industrial facilities in Quebec, Canada, and abroad. Please join me in welcoming Mr. Charron.
Bonjour, mesdames et messieurs. I will begin the introduction in French, and then I will switch in English. Il me fait plaisir de prendre parole ce matin devant vous. J'aimerais d'ailleurs remercier Dr. Amin Ahmad pour cette opportunité. Nous avons eu la chance de collaborer avec Dr. Ahmad sur des projets de recherche et ça depuis je pense que plusieurs années qu'on travaille ensemble. Puis, mais c'est dans la DNA, dans l'ADN d'Hydro-Québec, on a toujours fait de l'innovation. En 1965, on a inventé les lignes 735 000 volts. C'est maintenant le standard pour transporter de l'électricité. Ma présentation vous permettra d'avoir un survol sur les grands projets de construction au Québec, d'Hydro-Québec, avec des exemples concrets qui favoriseront leur réalisation et les conditions possibles, dans les meilleures conditions possibles. And now in English, it's my pleasure to speak before you today. I would like to thank Dr. Ahmad for this opportunity. We had the chance to collaborate with Dr. Ahmad on research and innovation project. As innovation has been at the heart of Hydro-Quebec mission since the invention of the 735 kV line, transmission line in 1965. My presentation will provide you an overview of Hydro-Quebec major project construction with concrete example of innovation that will facilitate their completion under the best possible condition. Our Action Plan 2035 is more than a roadmap. It's a commitment to the future. It is guided by five clear priority. First, we aim to improve the quality of services. This means massive investment in our aging grid to ensure it's deliver affordable, resilient power. Second, we are empowering our customer to use electricity more wisely. I think that's part of Marie-André way of thinking, that we need, through innovation and education, we want them to see electricity not just as a commodity, but as a resources and a precious one. Third, we must increase our generation capacity at least by 11,000 megawatt to meet the rising demand. Everybody want a new electrical car and they all want to connect them in their home. So that's a lot of power. We are launching projects that reflect both ambition and responsibility. Fourth, we're committing to partnering with indigenous community. This is not just about building project. It's about building relationship and fostering economic reconciliation with them. And finally, we're transforming Hydro-Québec into a more agile, transparent, and innovation organization, because to meet tomorrow's energy challenge, we must rethink the way that we operate. Let me be honest, the next 10 years is going to be very hectic. The road ahead is not smooth. We have a climate challenge. We have global supply chain disruption. We have labor shortage and geopolitical volatility, all present real challenge for us. Between now and 2035, we'll invest $200 billion to add 11,000 megawatt of new capacity. To put that in perspective, That's more than we spent over the last 40 years. Our strategy is comprehensive. We'll tap into energy saving. First, save as much energy as you can and reuse it. Second, expand wind power and solar power. Leverage storage and import. And third, enhance hydroelectric power. Transformation will also include upgrade to existing infrastructure, new generation station, and strategic partnership with Newfoundland and Labrador agreement. Each component is critical. Think about energy efficiency, grid upgrade, regional partnership, and of course, innovation. Together, they form an integrated vision for decarbonization and sustainable growth. Just to give you an example of what it means to spend $200 billion over the next 20 years, over the next 10 years, in 2010. Last year, we spent $4 billion. We had 2,200 people. So 2,200 people, 4 billion. At peak, we're going to be spending anywhere between 20 to 24 billion in a year. So that's 5-6 times. Let's say 5 times. So if I just do a simple math, 2,200, 5 times, that's going to be 10,000 more engineer, technician, and everything. That won't happen. So we're going to need to change our way of working. And that's why we're saying that we're going to need to change the way that we're going to be running the project. Let's begin with what defines Hydro-Québec, hydroelectricity. It's not only our legacy, it's our strength. In 2024, we invest over 1 billion out of the 4 to upgrade our existing generation station. This is not about just maintenance. It's about transforming them. By replacing aging turbine with next generation unit, then in 10 key facilities in Quebec, we're going to be adding around 2,000 megawatt of new capacity just doing that. And without building any new dam, without having a minimum impact. So that's mean that more clean energy with minimal environmental impact. That's the way that we're going to be helping the situation. It's about optimizing the infrastructure we already have to meet growing demand. Projects like Rapid Blanc, Carillon, Manic embody this approach. If you look at these three power dams, it's small one compared with James B. It's very, very small. It was built in the early 1900s. And what we need to operate them because we have them, so we will operate them. We're increasing their capacity, and they're going to be good for another 100 years. So we're working with hundreds of years of power. These projects are not just a technical upgrade, they're larger vision. They show that modernization and sustainability can go hand in hand. Every megawatt we gain from existing station is one that we don't need to generate anywhere else. That's smart growth. But we cannot meet our goal by just upgrading alone. That's going to be 2,000. There's going to be a 9,000 missing. So we need new generation as well. In Quebec, we're studying the feasibility of a 1,200 megawatt hydroelectric dam project and our very first 1,000 megawatt pump storage facility. That's a new technology. That's for the adding some puissance to the system. These projects will enhance our flexibility and provide strategic reserve. In Newfoundland, we're collaborating on several strategic projects that will significantly enhance the region energy infrastructure. The Gull Island generating station with a capacity of 2,250 megawatt will be built by Hydro-Québec and operated by Newfoundland Labrador Hydro. The project stands as a cornerstone for the region energy future, combining scale with strategic importance. The combining NHL expertise and LH expertise in operating their installation with Hydro-Québec, proven capability in dam construction. We're good at building dam. We build a lot of dam. We like building dams, so. And we have the right people to do it. So, okay, development of solar. It's not going to be enough just to develop hydropower. We're going to need to develop other things. So what we're looking at is, first, we're looking at the development of solar. Solar will, while it's newer in the northern region, it's poised for rapid growth. We are planning 3,000 megawatt through a first phase approach. We're going to be building small fleet, and then we will evolve in large fleet later. So we're going to do it this way. And the wind is quite attractive in Quebec. We have done a lot of survey, and actually there's a lot of wind in Quebec, all over the province. It's just to do it at the right place and to be able to transport the electricity back to where we need it. We're going to have, we are targeting an additional install capacity of 10,000 megawatt by 2035. So that's going to be quite a lot of power. And 4,000 megawatt is already in development. There's going to be 6,000 that we will develop in the coming month. It's nice to generate power, but you need to use it. When you say you need to use it, you need to bring it somewhere. So somewhere is all done by transmission line. So we have quite a good expertise, and we have developed quite a good expertise over the years with the transmission line. We possess 34,000 kilometers of line in Quebec. We have a large province, so it doesn't look too bad, but that's a lot of kilometer of high voltage tension. And we have 500 substations across all the region. To integrate new generation, we will be investing more than $10 billion on top of generation and everything. So we are prioritizing 3 strategic corridors. The first one is La Côte-Nord. Côte-Nord's got a lot of power, and there's a new capacity. And if you look at Gull Island, it's going to be on top of Côte-Nord. So that's easy to see that we're going to have to do something there. There's the Saint-Laurent Valley that's got some wind that we could bring back in the system. And there's the Appalaches-Bas-Saint-Laurent region that we're going to have to do the same thing. It's 850 kilometers of new high voltage, which represents 1,600 towers and 5 new substations. The expected spin-off is going to be about $7 billion for this part of the job. Now, let's talk about how we build. As we build, we must build safer. At Hydro-Québec, safety is more than a requirement. It's a core value. That's why we undertook a full redesign of our transmission tower with one clear goal: reduce risk for our worker. These towers are very high, and were stick building it to the top. So from the bottom to the top, they were always in the air, bolting the steel. We started by listening to the worker. We observed the way that they were constructing, and then we look at the engineering, how we did engineering, and finally what we decided was we're going to be prefabricating on the ground part of it and just lift it, put it in plate. So just doing this, you're reducing the time hang in the air, reducing the time that you could fall and hurt yourself. So that's the main. That's one of the main achievements we did on this. But that was the relation between redesigning, changing the way that we're doing it, and innovate in this. The results speak by themselves: faster assembly, fewer incidents, and better working condition. At -30, when there's a windshield and you're at the top it's not easy. So, and then the next one is safety also means building smarter, and digital technology play a key role. If you look, this is a civil equipment. We integrated advanced control system into construction machinery to prevent collision between the crew on site and the machine. So the man-machine interface, we're trying to avoid it as much as we can. These systems detect nearby workers, improving coordination between the operator of the shovel and the surveyor in the real time. Initial pilot showed strong result, few incidents, smoother workflow, and increased efficiency. Many contractors now are using this technology voluntarily, even when it's not required, just to make sure that they're safe. This is a shift from reactive safety to proactive safety. By embedding intelligence into our equipment, we're reducing risk before they happen. Going forward, our goal is to integrate across different projects. Drone. We're from small drone tracking construction progress to specialized model inspecting equipment at height. These tools are transforming how we operate. They allowed us to monitor hard-to-reach area, assess site condition, and reduce the need for worker to take unnecessary risk. One example is the line drone, developed in-house. It can fly over and land directly on the power line, 735, enabling inspection without shutting down service or sending people up there. The next step is to expand our use of long endurance drone with greater capability. That's going to help a lot to gather data, high resolution data. Last winter, we even did a trial to remove ice on that was close to Bécomo, between Bécomo and La Romaine. There was some ice on our 735 lines, and we broke it with those drones. So drones are getting used all the time. Prism is that's a robot that we develop at our research center that is going underwater. If you look at normally what you do is you send some divers, they go in and they work for weeks before because they need to go in and out all the time, and there's some very strict way of working. So what we develop is a robot that is doing exactly that same job, which is first it's we're doing cavitation cleaning and geometry measurement. We're measuring the residual steel thickness using ultrasound. So that's all done with robot. And the measurement of percentage of delaminated concrete using hammering technology. Some of the dam has RAG, which is a reaction alkalo-granulaire that could create a lot of pitting in concrete. So that's one of the things that we're taking care of. This is the innovation in substation and tower fabrication. The tower fabrication, we went to 100 different type, and we normalize it, standardize it to 40. So we are having only 40 and one common base for all of them. So we don't make any more mistake in building the base. It's always the same thing. We used to have different base, so a different base need, if you don't have, if you make a mistake, you have to redo it. So that was not very, very good. So, and this worked very, very well. The building in substation, we standardized steel frames and prefabricated the component. Control panel and protection relay and are factory tested to avoid costly delay during the commissioning and startup. This is the worker. We're gonna, if you look at building spending $200 billion, we're gonna need 10,000 unit for workers in campsite. The way building a couple of, like what we have presently is around 704 different camp. That's quite easy. You build them quite easily. But when you're getting to those number of 10,000, you better find a way of being very efficient at building them and moving them where you need them. So that's going to be modular, prefabricated camp, and reusable as much as we can. The other thing, this one is really the one that I like, is additive manufacturing and maintenance, commonly known as 3D printing, is opening new possibility in infrastructure and maintenance. Many of our components are decade old. When you're talking about Rapid Blanc built in 1926 and Drummondville in 1906, there's equipment that nobody fabricates anymore and the parts are not available. So this printer, there's where 3D printing step in, and we're using it more and more. And I think that in the future, for these applications, that's going to be the perfect solution. AI to meet, that's the artificial intelligence is also part of our toolkit. We launched a pilot project using video analysis to monitor worksite activity. All AI correlate footage with the project schedule and generate progress reports and flag delay. I think that's the next generation that we're going to be developing in the future. Innovation has been at the heart of Hydro-Québec since 1944. We built the world's largest underground station and pioneer 735 kilovolt transmission line, setting global benchmark in energy. The legacy continued today with AI, robotic, 3D printing, and safer design practice. But more importantly, innovation means collaboration. We work closely with supplier, contractor, indigenous partner, local community, and university to create solution. The ecosystem approach always allow us to deliver projects that are smarter, more inclusive, and more sustainable. We no longer see ourselves as a utility, but as a catalyst for clean energy, economic development, and reconciliation. Innovation is not just what we do, it's who we are. So, ladies and gentlemen, with the action plan 2035 to decarbonize the Quebec, Hydro-Québec is writing a new chapter. It's a journey where decarbonization meets innovation, where growth meets resilience, where reconciliation meets prosperity. Thank you very much. Merci beaucoup.
Thank you, Michel, for this excellent presentation. So we are done with the keynote. Thank you again. Now we have a surprise. So welcome, Spot, and we will have a small demo from Hydro-Québec. Please feel free to take to have photos or videos. And we welcome also Julie. Welcome. I'm very happy to see you because I sent her email during the weekend and she was kind enough to come and explain to us what's happening.
Thank you. So Good morning, everybody. My name is Julie Camille. I am the head of robotics and drone expertise in Hydro-Québec. I am representing Hydro-Québec. And I came today with my team. And I think like Mr. Charron said it, my team, and because Hydro-Québec is really involving and love innovation, half of my team is human and the other half is robot. So today, what we'd like to show you is what we can achieve when we combine robotics and LiDAR. This dog is a well-known robot. It's a Spot from Boston Dynamics. It's equipped with a Scan 3D and is realizing a 3D scan of the auditorium. So I will let you just show to the people what the robot can see and what the LiDAR can see.
Yeah, so on the robot right now, there's a RDC 360 of Leica Geosystem. We're gonna perform a 3D scan, but a few days ago, we scanned all the auditorium. So we need like in a kitchen show, we're gonna perform some stuff, and after we're gonna show you all the result of the auditorium. Yep. So right now, what you're gonna see is there's just stop right now. Yeah. Yeah, so to perform the scan, the spot need to be like on a stay right there because still, yeah. Sorry, I apologize for my English. So I'm from the North Shore of St. Lawrence River. We only speak French there, so in a small community. Yeah, so on the Leica 360, it's state scanner. It's possible to take it in all of project. There, it's possible to get like 5 millimeters precision. It's pretty common. It's a scanner of about like 6 years ago. You can also put on the Boston Dynamics like a Bailca to go and other scanner like that. But the Spot always need to stay on the place and just perform in some place.
During the scanning, I'll show you what the dog can see. So I'll connect the tablet on. This is what the robot sees with his different cameras. There's cameras all around for obstacle detection. And you can see there's a finger mark. So I can touch, let's say, on the stairs. And the robot's going to go automatically going up the stairs. As well, with the Spot, we can do automatical inspection. So we can say, go there, take a picture, come back home. Yeah, that's one of the features that are pretty interesting with the dog. And we have as well, you're gonna see in our stand, we have a charging station. So the dog gonna recognize the QR code. It's gonna go on the charging station, sit, recharge. And after when we need, we'll use it.
So these robots are not only pets or funny things. We use them a lot in a construction site, especially for surveillance. We actually have a few projects in Hydro-Québec about surveillance of the construction site. The one use micro drone to survey the evolution of a contract. We have right now 35 certified pilots, and we have the ambitious project to get to go to 100 in the end of 2027. Using the Spot dog, we use them in the power plant to make telesurveillance. So the dog is just completing survey. And the last but not the least project we have in construction site is about using dog Station 3. It's a drone in a box, and the drone will be able to survey the construction site in remote area and really isolated area. So we did not send any more people. It's about 4 to 5 people plus the helicopter pilot. So we let a box close to the hydrometeorological station, and the dock station is surveying the construction site. At Hydro-Québec, we are really lucky because, in fact, we have 2 types of unit. IREC is a research and development team. They are located in the Varennes, and they design and they develop new technology. Few of them are Prism, Riopel, but also Line Drone, Line Home, and Line Core Autonome. If you have more questions about this technology, you can visit us to the stand close to Molson Street. And our team is dedicated to operational things. So we take commercialized drone and robot. We take the robot developed and conceived by IREC, and we use them to conduct survey, to put our people safe and to be more efficient. So I think that now Tristan maybe will show you what the scan achieve. So these scans, we perform them in a difficult environment. We send the robot when there is a location really dangerous for human, or for example, when there is too much water or the air quality is not good. So instead of sending people, we send the robot, and we have like a mojo. This is the robot takes the risk, but not the human. This is really why we want them to work instead of human people. So we also use them in a BIM and digital twin, of course. I think everybody heard about that. So they scan sometimes the area, and then we reproduce artificially the area, and we can practice, for example, some exercise or some evacuation site.
Yeah, so what I show you right now is the scan we performed a few days ago. We took like about like 12 scan on all the auditorium. The Leica 360 also take 360 images. So so it was you in front. Yeah. You want to measure you? Yeah, we can measure you. Yeah. So right now I'm in Autodesk Recap Pro. It's pretty accessible for everyone to just looking at some 3D scan and also images. It's possible to adjust the scanning with Leica Register 360, but after that I can like only took a distance and like between feet. So you can see what it's possible to do like in civil engineering or any kind of conception. Like Julie said, you can go in a small place where human can go and take like everything you want for asphalt, for rock analysis, and few kind of stuff like that. So you're supposed to measure. Yeah, it's okay. Yeah, not your way. Yeah, Julie. Yeah, sorry.
Well, thank you so much for inviting us to this conference and at the ISARC.